Welcome to Massive Open Online course on fluid flow operations. So, in this lecture we will discuss about dimensional analysis and also law of similarity. As a part 1, we will in this lecture we will be discussing on the dimensional analysis. What is the actually that homogeneity of the dimension, what are the different methods of dimensional analysis, and what will be the other methods like Buckingham's pi method of dimensional analysis to be discussed here. Also, what will be the useful of this analysis of this dimension here, this is important. So, you know that any complex flow behavior in the real engineering, you will see that will accounted with where often a purely theoretical investigation fails to yield a practical and workable solution there. And you cannot have the theoretical solution sometimes for this complex flow phenomena. For that, you have to analyze the flow phenomena in such a way that sometimes you have to reduce some complex physical phenomena to the simplest and most economical form prior to obtain a quantitative solution. In that case, you have to know how to handle all those complex phenomena whenever any physical operations is taken place based on this complex flow behavior, and how to analyze on that to predict that certain output of that flow phenomena based on the flow behavior. Now, in that case dimensional analysis and the dynamic similarity are the two components which are extremely useful to the use and interpretation of the experimental data. So, in that case Brisbane 1969 he explained that this is the principal use of dimensional analysis, which is to be deduced from a study of the dimensions of the variables in any physical system. There are certain limitations on the form of any possible relationship that will be between those variables, and the method is of great generality and mathematical simplicity will be there. So, dimensional analysis is to be done to just reduce the complex phenomena of the fluid flow operation to its simple form. Sometimes you will see whenever you are going to do the experiments that experimental observation cannot be interpreted in such a way that you will not get the exact actually what will be the phenomena if you are considering it in a large scale in that case. So, you have to do some experiments in the small scale, and how to scale all those small scale phenomena to utilize for the large scale system. Now, like if you consider in dam, river, channels or hydraulic machines such as turbines, sometimes for large pumps it is very difficult to do the experiments. So, in that case, to know the phenomena of that dam, river, channels or hydraulic machines, in that case you have to do some experiments of those flow phenomena in the small scale in laboratory. So, based on that laboratory scale physical phenomena and interpretation, you can scale up those data to design or to analyze the system which is in large unit like dam, river and channels and other hydraulic units. So, for that you have to do in such a way that should be economical and also convenience, but it is required to know that small scale models should be tested in such a way that it will be useful for the same geometrical shape of that other large scale system. Now, in that case certain laws of similarity of course, you have to follow in order to ensure that the model test data can be applied to the prototype or not. And in order to apply those laws of similarities or that is or phenomena, you can say that you have to express the experimental results or interpret the experimental results in terms of non-dimensional factors. because that if you are having the dimensions for different physical properties of the systems or physical geometries of the systems are different, then you will not be able to scale up it to its large proportions. So, in that case, if you are making it non-dimensional forms, then only it will be possible to just scale it up by changing any dimensions of the systems. Now, dimensional analysis, that is why and the dynamic similarities are useful in finding such non-dimensional factors. So, we will be discussing one by one that how to do that dimension analysis, what are the different methods to analyze this dimension, and how to use that for the scale up in the subsequent lectures. And also, like if you are considering that blading of the hydraulic and steam turbines that are tested in a wind tunnel, where air is used as a fluid for the experiments. Now, these results based on these experiments are then converted to work the machines with water or steam, as the case may be there. So, whatever here fluid property you are using, the same fluid property or same based on that experimental observations of by using that fluid like air, you can use that results for the experiments which will be used for that experiments by steam or other gaseous medium. And this is possible by applying certain laws of similarity with the help of dimensional analysis. Now, it is sometimes useful to find whether an equation of any flow phenomena is rational or not. So, this is important. Generally, dimensionally homogeneous equation is called rational equation in that case. By dimensional analysis, the relationship between various physical quantities in an equation can be obtained. Now, rational formula for a flow phenomena can be derived by this dimensional analysis also. It helps in making a suitable smaller sized model in which experiments can be performed to predict the performance of the prototype. So, dimensional analysis, there will be a certain use for that. We can use this analysis for the branch of mathematics which deals with the dimensional quantities and also to find out whether the equation of any flow phenomena is rational or not. Generally, whatever dimensional analysis will be formed to make that final equations, you have to verify whether this equation will be rational or not, or whether it will be homogeneous in dimensions or not. That means, in the both sides of the equation the dimensions will be same. So, in that case you have to be very careful whenever the dimensions will be same or not. So, it is obvious whenever you are making the dimensional analysis and making the dimensionless groups there, you will see all the functions will be in terms of dimensions. In that case all the dimensional groups will be non-dimensional in both sides, whether in left side or right side, that you can easily then interpret, and also you can scaling up for the particular other larger scale. Now, to assess or measure an unknown quantities, we must have the acceptable unit in that case. So, whenever you are going to make any dimensional analysis, you have to use some units or quantities, in that case that should be acceptable in unit. Whereas, any suppose any systems you are any quantities if you are going to measure, that should be acceptable unit, not like that any arbitrary unit should be used there, that will be validated, should be on widely acceptable form. So, there are maybe different standard units you can have, but which standards to be used particularly, that also you have to be very particular in that case. So, you have to have the definitions and the convenience of using those quantities in the dimensional analysis. Now, out of which a small number of basic quantities that are to be considered as a standard quantities, and they are expressed in terms of basic units. Now, you will see there should be some basic units which will be used for analysis of this dimension, and those basic quantities are called fundamental quantities, which are only 3 in number. We know that mass, length and time. Generally, those fundamental quantities are expressed by the units that is m, l and t respectively, m for mass, l for length and t for time. Now, all the other quantities such as area, volume, velocity, acceleration, force energy and other derived units of these fundamental units will be units of physical properties also can be expressed in terms of these fundamental units that will be called as derived units, and that will be formed by either multiplication or by dividation of these fundamental units there. So, whenever suppose you are making units for what is that velocity. So, velocity units for velocity is simply length per time. So, in that case, what is the unit for velocity to be L per t or meter per second in that case. So, this meter is the fundamental units and second is the fundamental units. In that case, this meter per second is the derived units, those are based on this what is that fundamental units of length and time. Similarly, other units like force, what is the force energy units for force, energy, and also some other physical quantities like surface tension. What will be the units of surface tension? This is generally a Newton per meter. So, this Newton, this is simply kg into meter per second square divided by meter. So, finally, you are getting this derived unit of this surface tension. So, in that case, others let us see other different fundamental units are there or not. So, there are three conventional units that will be used for that primary, auxiliary or convenient fundamental units there. So, the primary fundamental units are generally length, mass and time, whereas auxiliary fundamental units are generally if you are going to measure a certain physical quantities like electrical, thermal or illumination or elementary particle disciples and also that are represented by the fundamental units, and these units are used only when these particular classes are involved. So, these are ampere, Kelvin, candela and mole. So, these are auxiliary fundamental units. This is not that based on that primary fundamental unit length, mass and time. This is separate units that sometimes to be used for the analysis of this dimension there. So, in that case electrical units you have to use for that fundamental as a fundamental, that will be ampere, and the thermal in that case Kelvin, illumination sometimes candela and other like concentration of these particles in a solution, then you have to use that mole in terms of mole. Now, sometimes whenever you are going to do the dimension analysis, you have to conveniently use some fundamental unit like that force. For a convenience you have to sometimes some engineers they are preferring to use quantity which is easier to actually measure instead of mass as fundamental quantity. In that case they are using force instead of mass. So, in this case the system is represented by letters here FLT instead of MLT. Here MLT means mass, length and time, where FLT is the force, length and time instead of MLT here. Now, some important quantities with dimensions are shown here in the slides in a table, like here in this here you will see the quantity, those quantities here length, time, mass, temperature, current, number of elementary particles, even luminous intensity. These are quantities, and what should be the unit for those? Length, unit for length is meter, unit for time is second, for mass kilogram, temperature is Kelvin, current ampere, number of elementary particles in terms of mole, and luminous intensity, that will be unit as candela. And for those, what should be the symbol for SI symbol? That meter it will be M, as second is for S, similarly kilogram kg, Kelvin K, ampere A, mole M and candela CD, like this. And for those quantity, we can divide those quantities into several categories like geometrical quantity like area, volume, second, moment of area, and also kinematics quantity like velocity, acceleration, angle, angular velocity, and also flow, and also flow quality, mass flow rate, all those things are kinematic. And dynamics like force, momentum, and also torque, energy, work, heat, power, and pressure, stress, all those are dynamic quantity. Sometimes fluid properties also will be used for analyze that. So, in that case you have to know the quantity of the fluid properties like density, viscosity, kinematic viscosity, surface tension, thermal conductivity, specific heat, bulk modulus. So, all those are these quantities are under different categories. In that case there are common symbols which are being used to analyze. In that case like area for A, volume B, like it is given in this table like this here. Similarly, what should be the dimensions respectively that you can have in this case. So, how to area, how to use these dimensions, like area is meter square, you can say that L square you can write here, volume V that is L cube. Similarly, what is that area, second moment of area, it will be L to the power 4, like that. What should be the velocity, what should be the dimensions for velocity? Velocity is nothing but meter per second, meter is represented by L and velocity is second, that means here t. So, here L by t. So, sometimes it will be represented as L t to the power minus 1. So, in this way dimensions are represented. Similarly, you can say that force, what should be the unit or dimensions for force. So, force is represented by F, and what is the dimensions here? Force, how to define a force? In that case here m L t to the power minus, that means 1 kg of mass is accelerated as A. So, in that case acceleration is L by t square. So, it will be m L t to the power minus 2 here. So, this is your dimensions here. So, in that case other also you can have like density, that is kg per meter cube. So, this is nothing but kg for m, and meter cube means L to the power 3. So, it will be coming as m L to the power minus 3. So, in this way these dimensions are expressed. So, you have to remember all those dimensions also, sometimes it will be used for that analysis of the dimension there. So, for dimension analysis sometimes you have to compare with these dimensions with other dimensions. So, that is why you have to know these dimensions of each quantities here, like what is the mainly density, viscosity, surface tension you have to know, and also velocity, mass flow rate, area or volume. So, it is very important to all those dimensions as per these tables you have to know. Now, before going to that dimension analysis, we have to know some basic what are those methods that are available to analyze this dimension. So, there are essentially two methods for analysis we will discuss here. One is Rayleigh's method, another is Buckingham's pi method. What is that Rayleigh's method? The method is based on the fundamental principle of dimensional homogeneity of the physical properties. In this case, you have to have for the analysis some dependent variables which will be identified and also expressed as a product of all the independent variables raised to an unknown integer exponent. So, equations will be made by equating the indices of n fundamental dimensions of the variables involved, n independent equations that will be obtained, and these n equations are solved to obtain the dimensionless groups. So, we will give the examples how system one by one, step by step, how to actually use this Rayleigh's method for dimensional analysis. And Buckingham pi theorem here also that relies on the identification of the variables here involved in a process. In that case, further a few of these have to be marked as some repeating variables or core variables there, and the repeating variables among themselves should not form a non-dimensional number in that case. So, if a physical process has n variables in that case and form these j are the repeating variables, then n minus j will be independent non-dimensional numbers that can be described here in this process. So, you have to form the dimensions non-dimensional groups by these two methods one by one, then we will be discussing here. So, in this case remember that both Buckingham's method and Rayleigh's methods of dimension analysis determine only the relevant independent dimensionless parameters of the problem, but not the exact relationship between them there. So, there will be just the functional. So, those dimensionless groups what are formed based on the analysis will be a function to each other, but you have to identify which group will be independent to the other variables there. Now, let us discuss that Rayleigh's method one by one. What is that? Let us consider a system. In that case, suppose any experimental observation, any experiment that is done in your laboratory. So, in that case, suppose you are having any experiment like this. If a flow rate increases, what will happen? The pressure drop in the pipe will be suppose increased, or you will see if you increase the diameter of the pipe, there will be change of pressure drop. If you increase the length of the pipe, there will be change of pressure drop. If you suppose use the different type of fluids, in that case you will see there will be a change of pressure drop. And of course, then you can say that the pressure drop is a function of what is that? Pipe diameter and fluid velocity and pipe length, and even you will see it is a function of physical properties of the system. So, whenever any fluid will be flowing through the pipe, then you will see there will be change of pressure drop. There may be other things also will be changed. Suppose if any chemical processes, like if you are going to do an experiment for suppose carbon dioxide gas absorption in a two phase systems in a gas liquid column. So, what will happen? You will see there will be a mass transfer of this carbon dioxide gas from the gaseous medium to the liquid medium. So, there will be a certain change of this quantity of that carbon dioxide from the gaseous medium to the liquid medium. So, in that case you will see there will be some mass transfer of gas to the liquid. Now, there will be some coefficient to represent that mass transfer phenomena. So, that is called mass transfer coefficient. Now, interesting is that this mass transfer coefficient will be changing with respect to what is that column diameter, flow rate of the gas, flow rate of the liquid, even you will see there will be a what is the geometry of the column, even you will see physical properties of the system. Suppose if you are using sodium chloride or sodium hydroxide, potassium hydroxide or some other liquid medium, then in that case what will be the physical properties like surface tension, density, viscosity, all those phenomena. So, all those physical properties that should be considered. So, in that case mass transfer coefficient is a function of what is that column diameter, even you will see that viscosity of the liquid, density of the liquid, even density of the gas, even flow velocity. So, all those things. Now, in that case, so you have to identify based on this Rayleigh method, if you are considering here, note all the variables first. Now, out of which you will see which one should be independent variables and which one should be dependent variables. So, here in this case, suppose this pressure drop is a function of diameter of the column, pressure drop is a function of what is that viscosity of the system, pressure drop is a function of velocity of the fluid. So, in that case pressure drop is a dependent variables, and independent variables are what? That will be your viscosity, column diameter or pipe diameter and flow velocity. So, these are independent variables. These independent variables will change these dependent variables there. So, if we consider that if y is a variable for a particular operation, if y is a variable that depends upon the independent variables, like maybe n number of independent variables will be there, maybe 2, 3, 4, 5, 6, that depends on the experiment, that experiment to experiment it will vary, and what type of experiment you are going. So, in that case if suppose y is a dependent variables and x1, x2, x3 and xn are those independent variables, then we can write a function like this: y is a function of x1, x2, x3 and xn. So, first step you have to identify what are those variables, and out of those variables what are the independent variables and what are the dependent variables. After that you have to make a functionality like this: y will be equal to function of x1, x2, x3 and xn. And then next step, that is as a step 3, what you have to do, write the functional equation in the form like this, like here y will be equal to c into x1 to the power a, x2 to the power b, x3 to the power c, not only xn to the power m. Here you do not know in these functions what should be the exact equality from this dependent variables with these independent variables. So, for that you have to make here there will be the exact equations here. What is that? Y will be equal to c into x 1 to the power a, x 2 to the power b, x 2 to the power c, x m to the power m. So, this is the exact functionality here. C is a constant, here also it is also dimensionless constant, and a, b, c and m are arbitrary exponents. Those exponents to be find out from the experimental data after fitting these equations there, and by some regression analysis you have to do, then you have to find out what will be the C, A, B, C, all those components. So, our objective is to find the dimensionless groups and making a functionality by these dimensionless groups. Now, then step 4, what you have to do, express each of the quantities in the equation in fundamental dimensions. In each the solution is required, in that case what you have to do, by using dimensional homogeneity obtain a set of simultaneous equations involving exponents a, b, c and m. We will give the examples later on one by one what to do. So, in this case you have to remember that you have to first consider the dimensional homogeneity, that means in the both sides of the equation, the left hand side and right hand side the dimensions should be same. So, obtain a set of simultaneous equations that will involving the exponents of a, b, c and m there. Now, solving these equations to obtain the value of exponents a, b, c, you will get how to find out that a, b, c value there. Now, formation of dimensionless groups by the variables with like exponents you have to have. Now, let us do this example here. Let us consider a frictional resistance F when a liquid is flowing through a pipe, depends on the viscosity, density of the fluid, velocity of the flow, diameter of the pipe and pipe surface roughness. So, in this case you have to derive a rational equation for the pipe flow in terms of dimensionless groups by this Rayleigh's method. Now, what you have to do now? First step is that you have to find out the independent variables and dependent variables. What are independent variables here? We have seen that the frictional resistance F is flowing through the pipe that depends on viscosity, density, velocity, diameter of the pipe and pipe roughness. So, here we can then identify here viscosity is the independent variables, density is the independent variables, velocity is the independent variables, diameter of the pipe is independent variables and the surface roughness denoted by epsilon is a independent variable. Now, dependent variables is F, because this frictional resistance, if I consider this F, then F should be the dependent variable. This F is depending all those independent variables. Now, next step what you have to do, you have to make the functional equation like this. F is a function of that F mu rho v d epsilon. Then what you have to do, the functional equation in the form of this F will be equals to c mu to the power a, rho to the power b, v to the power c, d to the power d and epsilon to the power e here. So, this c is the dimensionless constants a, b, c, d, e that you are just assuming those will be your what is that exponents here. Okay. You have to find out those exponents now in the next step, that you have to express each of the quantities in the equation in a fundamental dimensions. Now, what are those? This is the that is functionality. F will be equal to c into mu to the power a, rho to the power b, v to the power c, d to the power d, epsilon to the power e. Now, in this case what should be the fundamental dimensions of this F here? So, for this F what will be the unit that expressed in terms of fundamental dimensions, that will be m l t to the power minus 2. And if you say that how it is coming this m l t to the power minus 2, that you know that what is the definition of F? F is nothing but m into acceleration. So, what is m? M is mass, mass should be considered as m, a is the acceleration, acceleration is nothing but meter per second square, that means meter is L and second per second square, that is here t to the power minus 2. So, that is why it is coming as m l t to the power minus 2. Here C we do not have this fundamental, this is dimensionless. So, we do not have this dimensions here in this case C for C. Similarly, mu is the viscosity of the liquid. How it will be expressed this here? This m l to the power minus 1 into t to the power minus 1. This is the dimensions of the viscosity. How it is coming? Dimensions. The unit for viscosity is kg per meter second. So, in this case kg is what? M, meter is L to the power minus 1 here in this case, then m into L to the power minus 1 and then t to the power minus 1. So, it will be here simply viscosity, dimensions of the viscosity will be m L to the power minus 1, t to the power minus 1, then whole to the power a. Since we are here assume that will be exponent is a. Similarly, here rho is m L to the power minus 3, then 2 to the power whole to the power b. Here similarly, v is dimensions, what is the dimensions for v is L t to the power minus 1, then it should be whole to the power c. Similarly, d is the diameter of the pipe. So, what will be the unit? That will be length, the length dimensions will be L to the power d. Similarly, epsilon is the roughness factor, that roughness is nothing but the how much skin or scaling inside the pipe there. So, that will be very small minute. So, in this case you can say, if we consider this is the pipe. So, wall of the pipe will be scaled with some chemicals. So, that will be you know that there will be some roughness. So, that roughness will be denoted by the what is that small length. So, that is why its unit should be as L, its dimensions will be L. So, L to the power minus a here. Now, as a step 5 what you have to do based on the dimensional homogeneity, the simultaneous equations that will be involving a b c d e to be represented by these equations here 4 to 6 here. In this case first you have to equate these dimensions that is in the left hand side and right hand side. First of all you consider the dimensions m. Now, for then m in the left hand side of this equation number 3, what is the power of this m? The power of this m in the left hand side is 1. This is 1, this here in this case it will be power of m is 1. So, in the right hand side what will be the power of this m here? You are getting here in this case m to the power a, that means here a is the power of this m, here again power of the m is b, here power no other power. So, it will be only a plus b. So, here 1 will be equal to a plus b. Similarly, for dimensions L, if you equate the exponents or power of this L from this left hand side and right hand side, then we can say that 1 will be equal to minus a minus 3b plus c plus d plus e. And in the equation 6 we can again have these equations for time, just equating the dimensions of this time from this left hand side and right hand side, as this will be minus 2 will be equal to minus a minus c. Next what you have to do, you have to solve these 3 equations in such way that you have to express some exponents in terms of others. In this case you will see, if we solve this b from the equation number 4, then you can have b will be equal to 1 minus a. Similarly, from equation 6 we can have c will be equal to 2 minus a. Very interesting that we are expressing these exponents in terms of certain other exponents here. So, here b is as a function of 1 minus a. Similarly, c is a function of again a, that will be 2 minus a from equation. Similarly, from equation 5 we can have d as a function of again a and remaining exponents here. So, it will be 1 plus a plus 3b minus c. You just substitute the value of b and c here from this equation number 7 and 8, then we can have this finally 2 minus a minus e, because we are not able to find, we are not able to substitute the value of e from other equations. So, e should be remain same in that equation. So, only thing is that then we have to substitute the values of b and c from this equation 7 and 8. So, we are having this value of d in terms of a as well as remaining exponents like here e. So, finally, these three equations 7, 8 and 9 will be used for the exponents b, c and d in that particular functionality here. So, formation of the dimensionless groups will be then here if we substitute those a b that is b, c, d value in this exponents, then we can represent this f will be equal to c mu to the power a into rho to the power here c rho to the power here it was there b. So, b instead of b it will be 1 minus a. Similarly, v to the power it was there c. So, v to be c instead of c it will be substitute 2 minus a from equation number 8. Similarly, for d, d to the power it was there d, d should be in terms of 2 minus a minus e, that is from equation 9. Similarly, epsilon to the power e, e we are not having any e equation there. So, we cannot express the remaining left here. So, at least you have to from these 3 exponents to be represented by remaining other exponents there. Even sometimes you will see there you have to be very careful that whenever you are going to express this exponents, now which exponents to be replaced by remaining exponents, that you have to identify. You can select the other exponent also. Suppose if you are representing this suppose c, d, e, e in terms of b and a, that also you can do, then you will get also similar type of dimensionless groups. Now, from this equation here that f will be equal to here, what is that? So, in this case here again you can have this f that is f that is expressed here in this case, you can rearrange this based on the exponent here. So, if we rearrange this based on the exponent, what will be the a exponents? So, all the a exponents to be here represented in this case. So, it will be coming as rho v d by mu to the power minus a and epsilon d to the power e after rearrangement of this equation. And then remaining other that is variables you have to segregate from that right hand side and with this f. So, you will see finally f by rho v square by d square it is also one dimensionless groups, and this one is one dimensionless groups and this one will be one dimensionless groups. So, these are dimensionless groups are formed. See f by rho v square d square, this is you will see just verify it, this will be dimensionless. Verify this rho v d by mu, this is dimensionless, epsilon d this is also dimensionless. So, these dimensionless groups are formed based on the rearrangement of this a, b and e here, a and e here. So, and remaining here in this case. So, very interesting that these dimensionless groups, how many dimensionless groups actually are formed here. You have to remember that how many total variables are there in your experiment. Suppose if there is 6 variables, based on this experiment there are how many variables 1, 2, 3, 4, 5, 6 variables. Then what will the fundamental dimensions that there? There will be only 3 fundamental dimensions, that is m, l and t, that means mass, length and time. So, in that case if you subtract that number of fundamental dimensions from the total variables, then you can have how many what will be the dimensionless groups will form. So, here 6 minus 3, that will be 3 dimensionless groups will form. So, accordingly you will see here in this case 3 dimensionless groups we are having here in this case. So, based on these dimensionless groups we can form a functionality of these dimensionless groups. Here this is one dimensionless groups and this f by rho v square d square as a function of rho v d by mu into epsilon d. Very interesting that rho v d by mu is a Reynolds number. Reynolds number is a dimensionless groups. So, this is the function of Reynolds number. So, flow resistance as a dimensionless groups, if you divide it by rho v square by d square, this will be one dimensional group. This is the function of other dimensionless groups. So, in this way you can make a dimensional analysis and make a functionality of the dimensionless groups. So, thank you for this lectures today.